Okay, let us discuss this problem. This is an easy problem. So this is related to some common ion effect. So this question says 2m solution of Na2CO3. So I have Na2CO3 and concentration is 2m. This is boiled in a closed container with excess of CF2. So this is boiled with, basically I am mixing this in excess of CF2, and CF2 is solid. So what we are doing is, I am taking one flask, this contains Na2CO3, and then I am adding some CF2 solid. So this is a CF2, and then basically this solution is boiled off. So if I boil this solution, so let us say this solution is boiled. So after the boiling, what is happening? So let us discuss. So with excess of CF2, this is boiled, so CF2 is taken in excess. And what is happening? So question says a very little amount of CaCO3 and NaF are formed. So what will be the reaction you will have? Na2CO3 can react with CaCO3 or CF2. So Na2CO3 basically can react with CF2, and you see it can form something. It will form, so this is soluble, this is solid basically, this is aqueous. So we will have NaF. So formed is, you will have NaF plus CaCO3. CaCO3 is solid and this is aqueous. This means you will have Na plus plus F minus. Now if you balance this equation, you have to multiply by 2 also. Are you getting? Now question says very little amount of CaCO3 and NaF are formed. So very small amount of CF2 gets dissolved. So what is happening? If you dissolve this here, this is a CF2 is solid basically. And if you boil this solution in the presence of Na2CO3, some of the CF2, very little, gets dissolved into the solution, and that if that is dissolved basically forms CaCO3, that is again solid, and NaF is not solid. So this is solid, and this is very little amount is formed. So very little. And this is also very little. So if I use this thing, that is this is found in very little, and I can use the assumption Na2CO3 concentration initially given is 2m. So even if very little amount of Na2CO3 dissolves or reacts with CF2, I can assume the concentration of Na2CO3 remains constant, that is 2m. So the meaning is this forms very little, this forms very little, can be translated in the sense that the concentration of Na2CO3 remains almost constant. Even if you have subtracted some x will be here, some x will be here, but x is so small that I can neglect this x with respect to 2m. So I can say concentration of Na2CO3 remains constant, that is remains constant. Are you getting? So this is almost constant, and this will be 2m. Are you getting or not? So you have concentration of Na2CO3 is almost 2m, and now things are very easy. So if you have Na2CO3 is 2m, so you can say CO3 2 minus, concentration of CO3 2 minus will be also 2m. Are you getting or not? Na plus will be basically 4m. I am not interested in Na plus, so Na plus will be 4m. Now question says calculate if the solubility product of CaCO3 is X. So now the question gives you Ksp for CaCO3, this is X, and molar concentration of molar solubility of CaF2 is by. For CF2, Ksp is not given, solubility is given. Solubility is given and solubility is by. So if solubility is given, you can calculate the solubility product. What will happen? So CF2, you can write the reaction, this is a solid, it will form Ca2 plus and it will form 2F minus. So the solubility is by, so this means this is by, this will be 2 by. So Ksp for this reaction, you will have by into 2 by raised to the power 2. So you will have 4 by Q. Are you getting or not? So this means now you know solubility of CF2 also. So solubility product for CF2, that is basically equals to 4 by Q. Are you getting or not? So let us copy this one and then I can go forward. So finally, what we have to find out, so question says, what is the concentration of F minus in the solution? So what is the concentration of F minus in the solution? So you have to calculate the concentration of F minus in the solution. You think yourself everything is given, so what are the things that is given to you? Concentration of CO3 minus, that is 2m. Solubility of CaCO3 is X. Solubility product of CF2 is 4 by Q. You have to calculate the F minus. I will give you a hint. You know the concentration of CO3 minus, and once you plug the value of this, you can get the concentration of Ca2 plus. And once you know the concentration of Ca2 plus, you plug the value here, you will get the concentration of F minus from this equation. So let us take 1 minute. How many of you are able to do this one? Now this is a pretty easy problem basically. So I think some of you can do. Those who are not able to do, let us see the solution, and those who are doing, please keep doing. No need to see the solution. So let us see. You know the concentration of CO3 minus, that is basically 2m. So concentration of CO3 minus is 2m. This is given to you. And KSP for Ca2 plus CO3 minus, for this is KSP is X. You check your copy, you will get the same thing. X is given to you, see here. So KSP for CaCO3 is X, and Ca2 plus is 2m. So this is Ca2 plus Ca3 minus is 2m. So you will have Ca2 plus is basically X by 2. So from here you can say Ca2 plus is X by 2. And now you know the Ca2 plus, you can calculate F minus, because for CF2 you can write Ca2 plus F minus raised to the power 2. This is the KSP for CF2, and CF2 KSP is 2 by Q. I have 4 by Q I have already calculated. So this is 4 by Q. Now plug the value of Ca2 plus is X by 2. So X by 2 F minus raised to the power 2. This is 4 by Q. So from here you can say F minus raised to the power 2 is equals to H by Q divided by X. Are you getting it? So simple. So F minus will be nothing but root over H by Q divided by X. Now see, this is the final F minus concentration you will have. So this is a pretty easy problem. You have to calculate the concentration of F minus. What are the things that is given to you? So you have initially you have NO2CO3, and you are boiling NO2CO3 with CaCO3. You are boiling with CF2, and CaCO3 is formed, that is again insoluble. And okay, let us copy this. So if you have copied this problem, then we can discuss the next problem. Let us copy fast. So this is something related to the common ion concentration, common ion effect. You see Ca2 plus that is coming from CaF2 is very less. So in this case CO3 minus is basically acting as a common ion, if you see here. So let us see this problem. So CO3 minus, that is acting basically as a common ion. So CO3 minus concentration initially is very high, 2m. So whatever the CaCO3 that is formed, now it will have very less chance to get dissolved. So dissolution of CaCO3 basically can give Ca2 plus CO3 minus. But CO3 minus is also present in the solution from the beginning. So CO3 minus will act as a common ion. So Ca2 plus that will come will solely guided by initial CO3 minus. So I know the concentration of Ca2 plus, and once I know the concentration of Ca2 plus, and there is another equilibria for CaF2. So Ca2 plus, if I plug the value of Ca2 plus, I will get the value of F minus. Now you see, Ca2 plus that is coming from CaCO3 is again acting as a common ion for CaF2. Because if you have CaF2 initially, no Ca2 plus. So for CaF2, Ca2 plus is acting as a common ion. For CaCO3, CO3 2 minus is acting as a common ion. So in this question, you see, for CaF2, Ca2 plus is acting as a common ion. For CaCO3, that is CO3 2 minus is acting as a common ion. So these are basically common ion. Are you getting or not? So these are the acting as a common ion. Okay, let us copy this one and then we'll discuss the next problem.